All right, I wanted to spend a little bit of time and try to review a little bit of exactly what order of operations is. A lot of these math puzzles that I've been writing out some solutions for, they're really all based on a convention that really began back in the 16th century that's known as the order of operations. And I want to get into that here a little bit in our little math puzzle crash course. The order of operations convention allows for people all over the world to get the same answer to a problem. So no matter what language they speak, what continent they're on, they should all get the same answer. Uh, there's a structure to this convention that's been developed, and it started back around the 16th century. It started showing up in a lot of algebra books back in the day. There's a lot of confusion and wrong assumptions about the use of order of operations, about this convention, a lot of confusion. It's known by many different mnemonics around the world. In a lot of English-speaking countries, there are various mnemonics. Some of those that I'm familiar with are PEMDAS, BODMAS, BEDMAS, and BIDMAS. I'm not super familiar with where they're all from. I think like maybe in the UK it might be BODMAS or BEDMAS. I can't remember exactly which. I know in North America it's typically PEMDAS. PEMDAS is parentheses, exponents, multiply, divide, add, subtract. It's also there's an acronym that's called Please Excuse My Dear Aunt Sally that's used to also memorize that. And I believe, and I might be slaughtering this, I took 3 years of German, but I believe it's punkt for strich, something close to that. I think it's interpreted as point before line. I think that's a representation that's used. Somebody a little more familiar, better at German than me, it's been 40 years, could maybe fill that in and explain that to me, but I believe that is a representation that they use for order of operations. But basically, all these different mnemonics, the acronyms, they're all describing um, the very same order of operations. And there's only 4 steps. Okay, a lot of people, I really don't like these mnemonics because they're confusing to people. They memorize the order of 6 letters, and when they do that, um, they get confused. They think that multiplication comes before division, or if they know BODMAS, then they think division always comes before multiplication, and that's not true. The convention works like this. Okay, number one, you work anything that's inside parentheses. Number two, exponents. Number three, multiplication or division left to right. Then it's addition or subtraction left to right. And like I said, the mnemonics often confuse people into thinking, well, there's 6 letters or 6 steps to order of operations, but there's actually only 4. And again, it doesn't matter. I've heard people say, well, I learned BIDMAS. PEMDAS is a joke. It's BIDMAS. It doesn't matter which mnemonic you learned or where you were taught. The order of operations convention is consistent all over the world. Okay, and that's a good thing because we want people getting the same answers when we're working on problems, right? And these math puzzles, these aren't real world things, but like, real world problems, we want people getting the same answers. So again, multiplication and division are the same operation, and that's why they have equal precedence. I can multiply 10 times 2, or I can divide 10 by 0.15, or zero point 0.5, I should say. It's the same thing. So multiplication and division is the same thing. My answer is going to be 20 in both of those cases. So when solving a problem that has multiplication and division in it, you look at the 4 steps of order of operations, and when you get to multiplication and division, whichever one is to the leftmost, the first one that you encounter going left to right, then that's the one that you do first. Okay, that's the general way that order of operations works. And that's true of BODMAS, BIDMAS, BEDMAS, PEMDAS, doesn't matter. Addition and subtraction are also the same operation. They have equal precedence again. Subtraction is it's the same thing as adding a negative number. So think of a subtraction as the same thing as addition. If someone tells you that division always comes before multiplication because BODMAS tells them so, or BEDMAS tells them so, uh, or somebody else tells you multiplication always comes first before because PEMDAS tells them so. Again, though, that's wrong. And those people, they fail to understand how order of operations work. They just memorize the order of 6 letters, so they don't realize it's a 4-step convention. Uh, Also, I want to cover this a little bit too. It needs to be remembered that there are not multiple methods of education around the world regarding order of operations. This is a very consistent standard. It's very common to see someone in a forum, especially on Facebook, say, in my day, the answer was X. Or when I went to school, the answer would have been X. Or before all this new math, the answer would have been X. The answer is X using the old school math that I learned. My best explanation for all of these similar statements and the many forum threads where these people always congregate and pat each other on the back for their false memories is what's called the Mandela effect. I don't know what else it is. I see many people chime in on these threads and they'll say things like, yeah, I learned the old school way as well, just like you, and the answer is X. Or I grew up in the 50s just like you, and the answer would have been X. I grew up in the 60s just like you, and the answer would have been X. Or I grew up in the 70s just like you, and the answer would have been X. Um, many of these puzzles that end up on Facebook have a gotcha to them, such as a lack of parentheses, etc., that will send some people into a fit. They simply just don't remember how order of operations works after many years. It might have been decades since they went to school, but yet they will say, "In my day, you didn't need to have, you had to have parentheses, or you just solve left to right." Um, they simply just don't remember after many of years. That's really what it is. But it's not in people's nature to admit that they don't remember what they were actually taught. And I've put out a challenge. I've had this challenge out for a long time in some of these forums. I put out a challenge in a lot of these threads for anyone to show me a textbook from the last 100 years, a legitimate mathematics textbook that does not teach order of operations. And no one has ever been able to produce one. Now, there are some that have typos and ambiguities, but there's not one that says, hey, you just go left to right, or hey, there's no parentheses, you just go left to right. Order of operations is all that has been taught in anyone's lifetime. There's just not that many incompetent math teachers in the world. What you're saying when you're saying something like that hey, there's no parentheses, you go left to right. You're saying I forgot, I didn't pay attention, or all my teachers were incompetent all the way through my education. Um, many people would be better served by just recalling a quote, something pretty close to this attributed to Marcus Aurelius. It is in our power to have no opinion about a thing and not to be disturbed in our soul, for things themselves have no natural power to form our judgment. So, basically what he's saying there is you have the option always to have no opinion. Sometimes people, they have an opinion and basically they just kind of dig a hole for themselves and it can be a little bit embarrassing for them. But I'd rather see people understand this stuff, just realize, hey, maybe I forgot. It's legitimate to say, hey, it's been 20 years since I took that. I don't remember. I don't use that every day. That's fine, It's fine to admit that, but I'm just providing this here so that people can go back and look at it and go, oh, that's how it works. Okay, I get it now. Um, one common argument that some people put forth, it just seems natural to go left to right. That argument's not very well thought out, and it goes against the order of operations convention. For example, take this problem here, 4 times 3 plus 5 times 2 plus 9 times 6. Uh, Using that bad argument of just going from left to right, I wrote right to left. Dyslexia, I don't know what, but basically the left to right. So if you do that, just go simply left to right. You're going to go 4 times 3, right, which is 12. Then you would add the 5. 12 plus 5, that's 17. Then you have a times 2, so 17 times 2, that's 34. So then 34 plus 9 is 43. 43 times 6 is 258. Now, I can tell you one thing. As soon as I change this problem and make it something real world, and especially if I involve money, all of a sudden, sometimes light bulbs go off in people's mind. They go, "Oh, now I remember how order of operations works." Because, here we go. Here's an example. I bought 4 Diet Cokes for $3 a piece, 5 iced teas for $2 a piece, and 9 cheeseburgers for $6 a piece. Okay, don't argue the prices. I don't know why they're what they are. But anyhow, that if you want to write that problem out, it's 4 times 3 plus 5 times 2 plus 9 times 6. Now, if you use order of operations, you're going to do the multiplication first and then the addition. So that means you're going to do 4 times 3, that's 12. You have another multiplication, 5 times 2, that's 10. You have another multiplication, 9 times 6, that's 54. So what would that be? 22 plus 54 is 76. So I spent $76 on lunch that day. Okay, I was generous. I like my friends, whatever. The poor souls who don't remember order of operations just left the restaurant and they paid out $258 and they felt really good about it because they know how to do math, or they think they do. So, right there, they spent 258 bucks because they went left to right. Um, so that's totally wrong. There's another good way to look at order of operations because some people go, well, gee, I still don't get it. Like, why would you not go left to right? Why do I have to stop and consider multiplication or division? Well, a really good way to look at it is to realize that multiplication is nothing more than repeated addition. It's trivial to replace all the multiplication and division with addition. So you can write like 5 times 5, 5 times 5 equals 25. You could write that out the long way and go 5 plus 5 plus 5 plus 5 plus 5 equals 25. Both are the same thing. They're equivalent. Multiplication is just shorthand for addition. And we've already said before that multiplication and division are the same operation. So using that same idea on the problem we just looked at, we've got 4 times 3 plus 5 times 2 plus 9 times 6. So you got 4 plus 4 plus 4 plus 2 plus 2 plus 2 plus 2 plus 2. That's 5, adding 2 5 times. Then we're going to add 6 9 times. So all those sixes, that equals 76. It's the very same thing as what we had before. If you solved left to right, you're ignoring the shorthand status of multiplication. So the next time you're in a forum, feel free to post a link to this video if you'd like. I hope this has been helpful. I hope this helps explain a little bit of the background. There's a lot more to it, but there are some ambiguous things that pop up. But most of these problems that you see on these puzzles, they're very straightforward. So I hope this is helpful. Please leave any comments. If there's any kind of puzzles or things that you'd like me to work out, I do try to find them on Facebook, and I have some friends that send me links to them, and I try to cover them if I can and provide some answers. So I don't have any regular schedule for getting these videos out. I just do them when I can. But good luck. Trying to keep this under 15 minutes right now. That's all I'm allowed. So good luck.